Our first speaker today is Adrian Cockcroft. He is Vice President of Cloud Architecture Strategy at Amazon Web Services. Adrian started his career in the US at Sun Microsystems. Now, if you've been in tech a little while, you may recognize his book, the Sun Performance and Tuning book with a Porsche on the front. So if you're in the Unix world for a little bit, you probably recognize that. Some of you may also recognize him from the work he did at Netflix. He was heavily involved in Netflix's AWS strategy and did a lot of speaking himself and his team on what they did during their transition and why. After Netflix, Adrian spent some time with Battery Ventures, and he was promoting a lot of the ideas and concepts that he had developed while at Netflix and beginning to bring that into the startup community. But in 2016, Adrian joined AWS, and where he is now. But he's been spending a lot of time with the community, talking about open source technologies and what Amazon is doing there. And today, he's going to talk to us about insight in how organizations can innovate quickly, something AWS knows extremely well and something Adrian's been deeply involved in. So please join me today in welcoming Adrian Cockcroft.
Thanks very much. Thank you. All right. So just need my slides up. Well, thanks. I like to get out to a DevOps Days every year, somewhere in the world. So it's great to be here, and it's good to be back in Texas as well. Actually, I have my little Formula One logo. I was here last fall for the Formula One race in Austin. So I don't have any more on this, but we started sponsoring Formula One and holding executive events at Formula One races around the world. So I've been having some fun places to present this sort of message. But today I'm going to talk about speeding up innovation. I spend a lot of time talking to companies around the world, and so far no one has said they wanted to slow down their innovation rate. It seems like, but they're all struggling to go fast enough to keep up with all the demand. So I'm going to talk a bit about why that is, a few of the things that are blocking people on the way, and then sort of the stages we go through. And I have quite a lot of content, so I'm going to be going pretty fast here to hopefully finish in the time. So what's happening? If we look at the old world of IT, what we had was we were managing employees while they were at work, all the desktop PCs. We had factory supply chain management. We were managing sales channels through physical locations like shops or travel agencies or something like that. And those were intermediaries. We didn't actually know who our customers were. We were working through those intermediaries. So you had an IT operation that scaled with the number of sales outlets you had, for example. And then marketing was based on TV and print advertising, relatively slow turnaround. So we built out IT in the previous few decades to operate at this to deal with these concerns, right? So what happened, and this is my kind of digital transformation slide, if you like. We're now building mobile apps to make our employees successful, lots of different ones for different types of employees. People are continuously connected, so there's much more activity just making employees productive. And then the supply chain is now very detailed management, very much just in time. There's just a huge amount more information about whatever it is we're doing as a business. Sales has now gone online, so now we know every customer that we've got directly. We ship directly to them. We have a personal relationship with the customer. We're not going through those intermediaries anymore. And the things that we make are connected. So my favorite example is to basically think of a company that made door locks for the last 100 years. They make bits of metal, precision metal, they put them in a box, they send to Home Depot, and they hope they never see them again. If one comes back, it's because something broke and something wrong with it, right? So that's a problem, right, if you ever see it again. Now, if they don't hear from it every 5 minutes, it's a problem. Because it's connected. They put it on the door. They know how long it is before it goes on the door. They know they're managing battery life. They're doing over-the-air software updates to all these locks that are all connected locks. So If you think about that as just a metaphor for the kind of transition, industry by industry, you used to just ship something to some anonymous place, hope you got paid for it, and try to figure out a better product somehow. Now you have this stream of analytics about exactly what your product is doing, and everything is now in the scale of every customer you've ever touched and everything you've ever made. That's the new scale for IT. And then marketing is now online, so if somebody says something about your company on Twitter or Facebook or whatever, you've got to be able to respond to that immediately, not next week or something like that, like you could do with a print ad and that kind of thing. So everything is sped up. So if we look at that, what we have to figure out, these are the drivers. And you hear the word sort of digital transformation bandied around. This is, for me, kind of what is really driving it. We now have the ability to personalize for the customers because we know how they're actually using the product. That means we need very detailed analytics where we can actually collect all the information about exactly what we've made, who we've sold it to, how we've been able to personalize and build that. If you just think about the time I spent at Netflix, Netflix was really the first TV company that knew exactly who watched what. Right? Because previously you put it on TV at 9 p.m. on a Thursday and asked Nielsen how much you could charge for adverts. And that was pretty much the feedback loop you got. Now Netflix knows exactly what you watched, and you watched enough of this show, here's a new thing you've never heard of, you'll probably want to watch that. They can run all of those things much more detailed because they have a direct channel to their customer. So overall, for IT's point of view, more things, not just a few more things, but orders of magnitudes more things, maybe 100 times more things or 1,000 times more things to manage, much larger scale, and much more rapid change. Rather than having products that turn over maybe once a year, you're doing continuous delivery, you're updating things every few minutes or every few days or whatever it is that's needed to be competitive in your particular industry. So given that context, so what I've been working on with AWS is trying to unblock this innovation with a lot of our customers. And what I found is there are these three blockers. And looking at the theme for the conference, I think this is a lot of these things come up, and DevOps comes up a lot in the conversation. But I'll run through these in turn. So culture, skills, organization, and risk. By the way, I post all my slides or some of my slides to GitHub because I figure Microsoft owns GitHub, so I should be able to do a pull request against PowerPoint one day. It's a theory. So if you're Adrian Co/slides, I'll put these slides up there afterwards, so you'll be able to kind of rummage through and see how this. I have a company that makes my PowerPoint look good. You can kind of stare at that and see how they do that too. So let's look at leadership systems and feedback. These are the problems people are trying to overcome. You've got a lot of organizations with centralized, slow decision-making. They're low-trust organizations with very inflexible policies and processes. And you have to get past that in order to be able to run at the speed. I mean, maybe if you're doing a product release once a year, this works, but it doesn't work when you're running at the speed we need to today. So there's some books to read. I have lots of books. I have a list, a URL at the end to my book list, my reading list. But Ahead in the Cloud by Stephen Orban is really just a bunch of best practices in cloud transitions, lots and lots of good ideas in there. And then Mark Schwartz, who many of you may know from a lot of the DevOps conferences, he did a book called Seat at the Table about how to be an agile CIO. Then he just came out with a new book called War and Peace in IT, which is really aimed at the rest of the business about how to use IT competitively. So it's written for the rest of the boardroom, effectively, or the rest of the executive suite. Really good writer. If you haven't seen Mark, you should go watch him. He was introduced at one of the first DevOps conferences as, here's the CIO of Department of Homeland Security. And we thought, oh God, this is going to be a boring talk. And if you've ever seen him talk, he's one of the most entertaining speakers around. So that was a really cool person to get to know. So if we look at culture, this is actually a quote from the Netflix culture deck. If you want to build a ship, don't drum up people to gather wood, divide the work, and give orders. Instead, teach them to yearn for the vast and endless sea. And the idea here is you inspire people, you tell them where you want to go, get out of their way, and they build a better boat than the one that you would have made if you were micromanaging them. That's the idea. This is the principle that Reed Hastings uses at Netflix. It's a very powerful idea that you're trying to enable your employees to be the best they can be. And it's one of the competitive advantages of Netflix, because a lot of companies just never seem to get this. But anyway. Here's something from the Nordstrom culture deck, and it really distills their culture down to one thing: use good judgment in all situations. This is the essence, I think, of a lot of good cultures, is that they let you use your judgment. Right? If everything is over-prescribed, you have to just follow the next step in the run book, then you're not actually using judgment. And those are the things, as you run into a situation that isn't in the run book or that there is nothing written down for, and all of a sudden you're supposed to use perfect judgment, but you've had no practice in using your judgment up to that point. So creating an environment where there are fewer rules and more discretion for the employees is part of letting you use your judgment every day, and it means you're much more adaptive and you're much more able to manage whatever comes at you during the day. So this is, just to kind of summarize, this is the Netflix culture. Freedom and responsibility is one of the key things here. Think of trust but verify. Netflix trusts its employees very high level, but it verifies that they did do the right thing. So every decision you make is going to be looked at, right? That's the verify part. That's the responsibility part. We don't just let people run around and do random things, but everything you do, you have to be able to justify why you did that thing later. And that makes that control, that feedback gives everybody a lot more management for what they're doing. This is the Amazon culture. It's really a series of leadership principles. So the Netflix culture is really oriented around a company doing one thing. It's a very focused organization. If you're a startup, the Netflix culture is a very powerful one, because if you're building one thing, you're really in one location, you can build a very high-trust organization. Amazon is a huge, sprawling, do-everything company based around the world. We have 600,000 or 700,000 employees now. But any employee, I can go to them and say, show me what your bias for action, show me how you've learned, how you've been learning to be curious, think big. All of these principles are taught and hired for and promoted for, and the interview loops and all of the reviews and everything, and when all the internal documents refer to them, it's repeated over and over again internally, because this is how you gather together an extremely large and diverse organization. So this is kind of the operating system, the common operating system for Amazon. So if you've got a very large, sprawling, diverse organization, you need to have some common principles that you know that you're running against. And the top one, customer obsession, is the main one that everything revolves around for Amazon. If you ever think, why did Amazon just do something, you're pretty sure that there's some customer obsession is like the underlying reason why we do just about everything. We found a customer that wanted something, so we're doing it for that customer. So the key thing here is be intentional about culture, otherwise you'll end up with warring tribes. If you just keep acquiring companies that have different cultures and smash them all together, or you destroy your culture, fracture it, you get very this warring tribes kind of culture. It's very dysfunctional. It should be appropriate to the kind of organization. So if you're a small, focused organization, I spent a lot of time looking at Netflix culture. If you're a large, diverse organization, I'd look at Amazon culture as sort of examples. And then judgment is one of the root things. Like, how does the culture support you exercising judgment? That's enough on culture. Very quickly on skills. Particularly on new technology and cloud, just one example, really getting existing employees, getting out of their way, giving them time to learn new things is really important. And we found that's the best example. And you fund Pathfinder teams to get things built, to try out new ideas. But one of the problems you get is you train up all your good people, and then they're now highly trained people, and the company down the road hires them for an increase in salary, right? So you have to understand that highly skilled people who are keeping up with the latest technologies have a higher value in the market and have something to try and hang on to them after you've trained them. Just be intentional about that. Some kind of program, if you can give stock out, or you can do some bonus scheme, or some little, whatever it is, even if it's really more gamified, but something that makes people feel appreciated, because that creates an internal incentive to go and train yourself in the new technologies, as well as helping retain people that are your most valuable employees. There's a market for talent, right? And you have to recognize that market. This book, if you give this to your HR department, almost any organization, you can actually watch their heads explode if they actually read it. It's just incredibly, this is the most disruptive book in HR and talent management for years. So it's kind of the way Netflix runs. Netflix culture is incredibly hard to copy, almost deliberately. Well, in fact, deliberately. They deliberately did things that were hard to copy, but it really annoys everyone else that wants to copy Netflix. Anyway, let's look at the organization. Moving from projects to product teams. You want to have long-term product ownership. You don't want to have a team that works on something and then as soon as it's delivered, they scatter and run away and now operations gets to run it, right? You want to do continuous delivery, making the product slightly better every day. DevOps, run what you wrote. That's the version of DevOps that Amazon and Netflix and other companies have done. It's like if you're a developer and you built a thing, you're responsible for that thing. And that continuous responsibility and continuous delivery means that you actually get much less tech debt and lock-in in the system, because lock-in happens when development hands something over to operations and you dissolve the team at the end of the project. That's where you really turned the key in the lock and manacled everybody to whatever design decisions were made as you built that project. Right? If you're doing continuous delivery, you're continuously managing your dependencies. You're doing your micro-dependency management, right? Rather than the sort of monolithic enterprise lock-in. So continuous delivery lets you continually pay down your debt as well. So project to product, hopefully some of you know Mick Kirsten, obviously the DevOps handbook by a whole bunch of people, but mainly Gene came. So what does it actually look like? If you look at AWS service teams, yeah, they're DevOps, but they're not just DevOps, they're BizProd DevOps or something, whatever. They have the business. Each team at AWS is a business. There is no separate business out there that we built a DevOps team to service, right? Every team has a business manager, and every year they're given a budget, a headcount, some goals, revenue or growth or some kind of goals, depending on whether they're internal or not, or whether the service is a charged-for service. They have a product manager who manages the customer input and the roadmap for what they're doing, right? That's part of that team. There obviously is development, and there's operations. Operations, global support, they're on call for their service. They're the frontline support. And this is a team of, they call it a two-pizza team. It's maybe of the order of 10 people, right, at the base level, with all of these things in there. So how does that structure work? The org structure, this is sort of a very rough view of the way the structure looks at AWS. So Andy Jassy's the CEO. We have sales and marketing are separate things. And this product marketing is trying to gather all of these services that different teams have created and make sense of them to the customers, right? So we're trying to gather them together in groups and explain how you use them together. That's sort of product marketing's job. I actually report into that part of the organization right now. And then there's a services VP who owns all the services, or several services VPs, and there's a services general manager who has a group of related services for something, say like S3 or EC2. And then under that, there's an individual service manager and within that, you have the product development and operations, which is driven by an API. Right? And the way you talk to that team is through their API. You can have a meeting with them about their roadmap and their features, but that's the same as a customer having a meeting with the team. So internally, every team works with external customers and internal customers in roughly the same way. Right? So this is, this seems kind of normal to some people and totally radical to other people. But I just wanted, people talk about the two pizza teams and DevOps, but I think people weren't really realizing that the product and the business is built into that team as well. And all the way up. So every layer, every level has product development and operations all included. So there's no separate thing called the business at Amazon. And that's something that we've seen. Now, that may not be possible at your company, but one of the key things you can do is get somebody, if there's a separate business and they have a product manager, sit that project manager with the DevOps team. Co-locate them, sprinkle them through the organization, put their desks amongst the team that's running the thing. Don't have them off in a separate building or a separate continent, right? So, anyway, that's organization. Let's look at this risk side. One of the things you'll run into sometimes, some companies are very capital intensive, and when you start moving to cloud and you speed things up, you're actually moving capitalized expenditure to expense cloud. But also this happens with DevOps, because you typically capitalize development and expense operations, and when you try and mash them together, then the CFO says, hey, hang on a minute, how do I, this is one team now and they're just working on stuff, and where do I capitalize and where do I expense? And There are ways of doing that, but if you're getting into this process and you haven't run into that, it's worth understanding the way that finance looks at this, because it will sometimes be the blocker that prevents you moving to DevOps. So just something to look at there. And I talk a bit about boards because I kept running into problems at companies, and it turns out the problems just kept working their way up. So if we look at boards and what boards are concerned with, they own risk for the company. They own compensation policy, executive succession, all these different things. And a lot of what they do affects your ability to innovate, but a lot of the best practices get in the way of that innovation. But one of the things they keep saying is, be more innovative. The boards tell the CEO, you need to be more innovative, like Netflix, Amazon, Capital One, but they don't actually operate the way that they do. So let's say, what's the connection? What you tend to find is very short-term focused compensation policy, a non-technical succession, so you have executives that have no clue about technology, even though technology is pervasive everywhere now. There's capitalization issues, no money to invest. We want no risks whatsoever and no failures, right? So that makes it a bit difficult to experiment, but we still want you to be more innovative, right? Even though we're not going to do any of the things that the other innovative companies do. And I love this little animation I got done here. I sent a very vague idea to the company that does my graphics, and they made this lovely deck. Anyway, we can't use cloud because there's a policy against it. We can't change the policies because there's an org chart. DevOps is really a reorg in most companies. We want to change from product to project, which means you need to get rid of a lot of project management staff. We can't change our org chart because of our culture or our lack of culture. And then we can't change culture because incentives aren't aligned, because you kind of get the culture you pay for. If you pay people to work in a certain way, they're going to, even if you tell them to do something else, they'll mostly do what they're paid to do. You can't change compensation because you get 4% a year to peanut butter across your employees, and that's all you get, and you can't, there's no way to be flexible there. And the boards won't change the policy because best practices are low risk. So a lot of these problems just keep going up to the top. So what I've seen, this is the practices of the innovative companies that people look up to that are being strategically successful. So if you're like trying to sort of tell the board what they should do, fewer higher paid staff and more ownership is one of the common themes. Technical competence in the executive ranks. Nowadays, you really have to have that. There's technology everywhere. Managing CapEx expectations and investing in differentiators rather than just building another data center because that's what you did 5 years ago. Smaller projects with incremental returns and focus on time to value. I'll talk more about that next. And what this really does is get out of the way of innovation. I'm tracking my time here. All right. Okay. So, best practices that minimize short-term risk get in the way. That's really the problem here. All right. So if we're looking at what actually happens as people get more innovative, there's 3 steps. The first thing is they learn to go fast, which is focused on time to value. Then they learn to build things at scale. And then finally, the strategic workloads, the back ends, the old stuff, a lot of data center replacement kind of workloads. So this is the pathways we're seeing in people that a lot of our customers are going through. So going back to this thought, hiring a VP of innovation will not solve your innovation problem, right? Getting out of the way of innovation will unlock it across your whole organization. Talking to somebody yesterday at the speakers dinner, they said, we've got old people that have been at this company for decades with ideas they've had for decades that are finally getting to actually implement some of those thanks to the whole DevOps program and their ability to get stuff out. I mean, that's exactly this point. It was great to hear this sort of validation, just getting out of the way. So the fundamental metric for innovation, I think, is time to value. Because if you do some work, how long did it take before that work made a customer's life better or touched a customer, right? That's a very clear metric. And a lot of organizations, it's months. I was talking to one company, yeah, we really, really want to go faster. And I go, great, well, how often do you release? Every 6 months. How often would you like to release? Well, lots of times a day, all right. Well, we've got a bit of a speed up to do here. And it says, yeah, well, how many tickets are there per release? 600. Okay, this is part of your problem. So days can be, depends what market you're in, what you're doing. You know, days can be reasonable. A lot of people, though, now it's minutes because you've got a continuous delivery pipeline. Every piece of code that's ready to go checks. You do test-driven development. It goes through. It rolls through the pipeline. It rolls out to production. Goes through some canary testing. You're done, right? So can you get to that? And this is the key point. There's no economy of scale in software. The more you bundle it together, the worse it gets. Right? You actually want to separate it into the smallest incremental pieces of work should be the things that you can push to production. And this is all great, and there's something like, this is wonderful, love this idea, except my software build takes 9 hours for my Java monolith. I went, okay, so we need to fix that. But if you're doing lots of changes, what you need is an automated pipeline. You need tagging, feature flags, A/B tests, right? Something like Launch Darkly. I just stuck the logo in there for Launch Darkly. Rapid, cheap builds. That's what you need to be able to do, and that enables everything. So now you're looking at breaking things up into smaller chunks and maybe microservices and whatever, because your Java monolith maybe takes hours to build, but if you build something in Go, you know, if you type Go build, it's, you know, you don't have time to go and get a cup of coffee. It returns in usually less than a second, even for fairly large programs written in Go. So you're moving from a huge build that takes hours to a smaller chunks of work which takes seconds to build, and that's part of this process. It's part of the technology refresh. And you also want to decouple new code from new features. You want to be able to roll out things continuously, but customers don't see the change until marketing's ready to turn on that feature after it's been tested for everyone to see. So your code's been running in production for weeks before you launch this feature to the world, right? It's been sitting there behind some feature flags or behind an A/B test where everyone's making sure that this really is a better experience than the old way of doing it. So what we're trying to do with small changes, that gives you less risk because the incremental changes are much easier to figure out, because if something goes wrong, you know it's that small change that broke something. Faster problem detection, it's much faster to repair. You've got much less work in progress because let's say you rolled something out today. Tomorrow somebody says, I need to change this piece of code, and they see your code from yesterday that's already in production, right? You're continuously putting code back into production. You've not got these long feature branches, so there's very little merging. Developers are happier because you change the world every day, right? There are some people I know who said, I wrote code for years, and I don't think my code ever reached the customer. That's really dispiriting kind of way to live, right? And you just get faster flow for the product managers. So how do we get there? I think the starting point, what I'm trying to get here is if you're a manager or an executive, like you should know what your time to value is across your organization as an average and as a team by team, right? Because some teams will be going quickly, others will be going slowly, and you want to just put a bit of, gamify it a bit, put some social pressure on people to let people know what you care about is short time to value. And if you just let people know that's what you care about, then hopefully that feeds down and people start optimizing for it. So the first thing is automate collection and reporting. Whatever ticketing system you have for check-in and for deploy, figure out what are those tickets, where are those points in the cycle, figure out how to measure that. Learn to do small things quickly. I gave this talk to one of the big banks, and they said, they told me a great story, which I'm going to repeat. So they said, we have this long, complicated process for getting stuff into production because we're a bank and you have to. But there's these easy things that we created a fast path for. And if you could basically prove this was a low-risk change, then you could get stuff to production in a week instead of months. And so we set this up for making easy, quick changes to stuff that didn't matter, like front-end websites or little things that were uncontroversial and safe. And they said, but what happened was, a few months later, or a year or so later, one of the teams came by and said, that big, complicated thing that we just delivered? We did it all through the fast path. We broke our entire project into enough small, safe steps that we were able to get the entire project through the fast path. And they were thinking they'd sneaked through and broken the system by cheating. They thought they were cheating. And it turns out that was actually what everyone wanted to do. And they didn't realize that you could take these big, complicated, scary projects and break them into steps where each step was so safe you could run it through their fast path and it went through everything. So they built an incremental way to get through. So this was an unexpected success for them, but it kind of, if you create a fast path, then just let people figure out how to optimize for it, right? That's the trick here. And then measure cost per deploy. If you're doing, an 11-hour Java build and whatever, how much does it actually cost you to do that deploy? How much build time, people time, how much time you're spending in meetings, how many people hours are there per deploy? Just keep cutting the meetings down, shrinking them, drive to reduce that build test. You really want one tracking ticket per deploy that says, hey, I checked in some code, and you do automatic additions to that ticket that records the fact that it deployed, right? If there's some SOX compliance or something like that, maybe you have to have a manager sign off at as one of the steps. But in many cases, it just flows straight through. And no meetings about a deployment. You have meetings about the roadmap and about the features you want and things like that. But deployments are happening every day. You don't have time to have a meeting with operations to hand it over to them, right, if you're doing stuff every day. So a bunch of books. I said I'll give you a link to all these, but most people should know about Lean Enterprise. Hypothesis-driven development, breaking away from your old ways of working. Barry O'Reilly, who's one of the authors on Lean Enterprise, kept just running into people that were stuck in the old ways. So he wrote this book, another great one. This actually did pretty well recently in the New York Times business book list. Let's see, Principles of Product Development Flow, really like the theoretical basis for using consistent small changes. Accelerate, I'm sure Nicole was mentioned, I guess she was here last year. Low latency time to value works. That's the key thing here. So what you're trying to do is learn to do simple things quickly to unblock innovation, avoid these complex one-size-fits-all processes, build fast paths. And the best IT architecture today, and this can be a little controversial if you have a central IT, enterprise IT architecture team, they're mostly the problem, because they're trying to create a nice, centralized, consistent architecture, and the best architecture is actually minimalist, messy, and inconsistent because it's designed to evolve quickly. But it does provide guardrails. You've got to have guardrails for secure. I don't care what you do, I don't care what language you write it in, but it's got to be secure, scalable, and available, right? So you put in the guardrails around those three pillars, and then everything else is, pick whatever library or language or whatever. It doesn't actually matter because you need to be exploring new technologies as they occur. Because the latest cool thing could come along and actually be really useful to you. But you still need to, obviously it has to be stable enough and it has to be secure enough. But you shouldn't have like an adoption review meeting and things like that. But this supports low latency continuous delivery. All right, so you've figured out how to do small things quickly. Now you're going to go build something a bit bigger. Because these new type of applications, the sort of IoT backend, mobile backend, Netflix streaming, global services, those kinds of things, they're highly scaled. They're extremely distributed. They're cost optimized. They have very high utilization. They scale. They're elastic. And they use a cloud-native architecture. So these are the net new applications I'm talking about. And the principles, cloud-based principles, pay as you go after you've used after you've used that capacity. You pay a month in arrears for everything instead of paying at the beginning of a 3-year process where you're going to depreciate something in your data center. Everything's self-service. There's no waiting to get hold of resources. It's globally distributed by default. If you need a machine in Brazil, you start a machine in Brazil. It's no different to starting a machine in Singapore or London or Virginia. They're all the same. Cross-zone and cross-region availability models rather than backup data centers. That's something new to learn there. Very high utilization, just shutting down everything, right, that you're not using. Your QA environment should be turned off 3/4 of the time because QA engineers should be working like 40 hours a week and there's 168 hours in a week. So what's the other 120 hours for? You should be shut down waiting for people to come back to work on Monday, fire everything up, and just fire up on demand, right? And then everything using immutable code deployments. You never update a machine, you deploy a new machine alongside the old machine, and the old machines are just working away, they're nice and stable. You try out this new one, you keep deleting new machines until you get something that works, and so it's that side-by-side sort of canary A/B test kind of deployment. So I'm now going to spend a few seconds about containers or serverless and how to think about using both of them. And I'm using an analogy, which is that we wanted to build something that looks a bit like a toy spaceship. The problem we're trying to solve is make a toy spaceship quickly and cheaply. I use this bit of analogy. So traditionally, you design a prototype, you'd carve it from modeling clay, you'd make molds, you'd produce some injection molded parts, you'd assemble the parts, find they don't fit together, go back, and like, okay, let's go and redesign it a bit, make some new molds. And you go backwards and forwards for quite a little while. But eventually, you finally get the thing finished and you put it out, right? So this is a fairly traditional kind of, the same kind of development pipeline we have for a lot of our software. But if you're doing rapid development, it's a bit different. You get a big bag of blocks, and you get some instructions, and you just spend a few hours, and there's your toy, right? The Lego version, right? So that's one of my favorite. I don't even know how they did this. This is PowerPoint going crazy, right? Okay. You can go look at the slides and try and figure out how they did that. But anyway, I just said I wanted a Lego spaceship. And there's this company called Silver Fox in Seattle that did this slide deck, and they're awesome. Anyway. It lacks some fine detail. It's got a few sharp edges. It's recognizable. It's not exactly what was asked for, but it's easy to extend. I can stick some bits on the back. So under this thing, now you can't arbitrarily make it any scale you want. Like if you're doing the plastic version, you have a total choice over the exact scale you want. This one, the Lego version, it has to be either this big or this big. There's really only kind of 2 or 3 different scales that work with the bricks, right? So you've got a lot more constraints. But you can take these bricks and say, you know, this bit here, that's just not pointy enough, right? I'm going to make a new custom brick. And you see this with Lego. They keep making sort of special new custom bricks for pointy things that didn't really work. So what you're building now is a new common component that's specialized, but you decided, you know, I need that pointy brick because I'm going to make enough of these things. All right, so this is kind of the 2 different approaches. Traditionally, you're doing full custom design, months of work. All these custom components need integrating, too many detailed choices, and really long decision cycles because everything is open, right? If you look at rapid development, you're constrained by the bricks, but you know the bricks fit together. You have to adjust your requirements to fit the patterns you've got. And the constraints actually speed up decision making. So this is about having a set of constraints that mean that you go really fast, because those bricks are just the way they're going to be. You're not going to call up Lego and say, I need a brick that's like 2 millimeters wider than the regular one. No, you're done. That's what you've got. So if you look at this between containers and serverless, containers are great for building custom things, and they're also great for building the optimization. But I think a lot of people now are building serverless first because you can rapid prototype in a few days, get something built, and then say, you know, this bit here, we should really build a container-based service for this piece because it really needs to be lower startup latency, or it's a long-running compute job, or there's a lot of traffic to it. It would just be more optimal to have a continuously running service for it, or it stores some state or something like that. But you end up with a lot of your business logic. But it's got rough edges, and you had to mutate your constraints and your design to fit what was there. So this is kind of the trade-off. But the effect you get, if you can do that, is you can go so much faster to get things done. So that's my kind of the way to think about it. You think of like rapid prototype and serverless first, and then build the container-based systems for optimizing it later, because that'll take you much longer. So I'm going to talk a little bit about observability, epidemic failure modes, and automation. Just see how much time I got left. Okay, I've got a few more minutes. So, right. So observability, this is the actual definition of observability from 1961. It's a system's observable if the behavior of the entire system can be determined by only looking at inputs and outputs. And that makes perfect sense in our context as well, right? I have a piece of software, and I have to understand its behavior And if I can't see, if I don't know why it produced that output, I need to add some logging or some debug messages or some tooling that can let me look inside that process to see why it's doing what it's doing. So that is the observability that lets me determine the behavior of the system, because part of the output now is some kind of logging or some internal state that's being exposed to me, right? So that's conceptually the way to think about this. And all of these models are wrong, right? But some models are useful, including the models they use in mechanical engineering, control engineering. Their models are also wrong, but the models have to be useful, right? So that's kind of, so the question is, how detailed should your model be so it's still useful enough that you can do something? This is a particularly interesting model, STPA model. It's got 3 layers in it, and this is the abstract version. I'm going to switch to a version that maybe makes a bit more sense to you. So let's say at the bottom we have a sign-up flow microservice, which is trying to get customers' email addresses. Yeah, you fill in an email and a whole bunch of stuff to register new customers. Just about every service in the world has one of these, right? So we have that flow. Customers are typing stuff in, and what you get out of this is new customers, right? And there's a number of instances running that. So above that, the next level is the autoscaler, some control system that is managing the number of machines which are handling the sign-up flow. And that autoscaler has max-min limits and control adds CPUs. It's watching CPU utilization. If machines get busy, it adds more, and if it shrinks, it goes down, right? Standard autoscaler stuff. And above that, there's a human controller that's probably looking at the throughput to make sure we're still getting customers signing up. So that's fine. This 3-layer model is actually a really useful way of mapping out everything you do, because it really puts the human part of the observability directly into view. Because the way STPA works, it says, what are the hazards that you could see in control? Meaning, some of the lines on here, something goes wrong with one of the lines, part of the information flow. So STPA looks at those hazards and tries to figure it out. So let's say the sign-up microservice doesn't run out of CPU, it runs out of memory. What happens? Well, the autoscaler just goes, we've got plenty of CPU. But the end user will see, well, our throughput's down, but they can't figure out why, because then nobody's looking at memory, right? So one of the hazards is that the resources that you're contending on is not the things you're looking at and scaling for. So there's those kinds of things. Or what happens if the sensor that's reporting throughput breaks for some reason, and now your operator can't see the throughput? So they freak out and they start rebooting everything in sight or whatever. The system's actually working fine. Or there was some other disturbance going on. So you can see all the different ways you could perturb this. Anyway, this is a really useful way, I think, of looking at managing the availability models for things. So just looking at observability, if you have a big monolithic application with lots of internal logic that isn't doing any logging, it's really difficult to see what it's doing, all right? If you add tracing and logging within that monolith, then you're getting into more observability. If you have a microservice that does one thing, it's actually more observable inherently because it says, do thing. Okay, I did thing, right? Do thing 10 times. Okay, I did it 10 times. It's much simpler to reason about and look at its inputs and outputs and map them. And if you have a function with no side effects, that is actually inherently a very observable thing, because the function of add, feed it 1 + 1, you're going to get 2 out unless something's very badly or wrong. You don't really need internal observability of something that's a function with no side effects. So just looking at failure modes, they can be independent, they can be correlated, or they can be epidemic. So I'm just going to go through this. This audience probably remembers some of these: leap second bugs, memory leaks in agents, I'm sure you've had that, zones, region failures, DNS failure, somebody pushed the wrong security config syntax, all these things happen, right? So how do you contain those things? Because these are like a crop failure, right? They're systemic, they're epidemic. So maybe you can also deploy that Java app on Windows so that if Linux happens to be crapped out today because of some big security bug, you can do it on there. Or Intel has a bug and you deploy an AMD or something. You have alternatives there. Monitoring tools. I always like to have more than one monitoring tool because one of them will break and you want to use the other ones to see that happened. Cross-zone, cross-region replication. multiple domains and providers for DNS. Make sure you renew your domain name. Like, think of yourname.com, whatever your company is. There was a SaaS provider that forgot to renew their domain name, right? It wasn't a happy day. All they had left was the CEO apologizing on Twitter. That was the only thing for 2 days. That was the only thing they had. Nothing else worked at all, right? Don't be those people. And limit the scope of deployments. Somebody said this once, to err is human, but to err and deploy globally simultaneously is DevOps or something. Anyway, but don't do that. Deploy in region, scope, stage things, do canary tests, roll things out gradually. Don't deploy stuff globally. So diversity has to be managed to contain an epidemic. That's really the key thing, right? If you think about all the epidemic-like things that are going around the world in disease and crops and stuff like that, it's managing that diversity that's important. All right, so I've got, I think, a couple more minutes. So just to wrap up quickly. This is something we're doing, the kind of stuff AWS is doing for going through everything Volkswagen does and replacing all their data centers, all their supply chain, moving it all to cloud. These are enormous projects which are strategic. This isn't a net new greenfield, cloud native application. This is factories, right? And we're moving old stuff. And it's like, have you got an AS400 emulator that runs on the cloud or whatever, that kind of level of stuff. Does anyone know Algol because we found a Burroughs machine or something? Weird stuff. So we're developing partners, pattern solutions and services for doing all this stuff. And, there's this problem. Do you have a backup data center? No one's got a backup data center. How often do you actually fail over apps to it? This is the answer usually once a year because the auditors make us. And we never fail over the whole data center at once. And I call this availability theater. So anyway. So once upon a time, in theory, if everything works perfectly, we have a plan to survive the disasters we thought of in advance, and it's not a good fairy tale for bedtime reading because it will keep you up at night. Forgot to renew a domain name. Okay, I've mentioned that one. If everyone hasn't had this, anyone hasn't had this one, right? This happens all the time, right? It turns out computers don't work underwater, and they don't work when they're full of sand and bits of seaweed either. So a friend of mine spent several months building a new data center that wasn't in a basement in New Jersey. So be careful. This is the most important thing, though. Fast detection and response is the best thing that you can invest in as an organization. And there's a few interesting things. Books to read, the network isn't reliable. Drift into failure. You do everything right, things will still break. Stuff about releasing things better. There's a second edition of Release It if you haven't seen that. And this is the book that STPA is in, Engineering a Safer World. It's a really interesting book. Nancy worked on the air traffic control system. I'm glad that works. She worked on that. And the system that doesn't accidentally launch nuclear missiles, that thing. Right, so there's some good stuff in this. It's a group at MIT. So what we're moving is from disaster recovery through chaos engineering that some companies are doing now as sort of like a special case thing, to, in the future, resilient critical systems. Everyone needs to be doing this. It can't just be sort of the unicorns doing chaos engineering. And this has been developing over the years. There's a bunch of different people working on it. But really, this is at all levels. You've got to be doing, at the top level, you've got to be doing game days, and all the way down, you've got to have resilient applications. You've got to be able to switch traffic around, and you've got to have resilient infrastructure, because you're only as strong as your weakest link. Right? And you need teams to find those weak links. And failures really are a lack of safety margin, and what you're doing is testing that you actually have that safety margin. And a failure mode, an actual failure is that you ran out of margin, not the proximate cause of, who did the bad thing, right? That's not actually what happens. So what you want is experienced staff, robust applications, a dependable switching fabric, and redundant foundation underneath. This is the area I'm spending most of my time actually working right now. So cloud gives you automation that leads to this, because the automation was really the missing link a lot of the time before. And as data centers move to cloud, that disaster recovery practice that was very manual and bespoke and handcrafted becomes automatable and repeatable because the APIs and the drift detection and all those things become really possible to do. And we're going to move from this scary annual experience to continuously tested resilience, where this is something where you know that if you need to fail over a data center, oh, we can do that, we can do that automatically, and we practice that enough that we're sure it's going to work, rather than being everybody gets scared. All right, so that's what I had. All those books and some others, that book list URL is, you may want to just try and write that down or something. But that's what I've got. So thanks